Our next presenter is Doug Thomas with Houston Engineering. Doug works as a consultant to the LASA Pilot Sustainability Project and has assisted with the environmental components, which included using Field to Market's Fieldprint Platform for developing and assessing on-farm sustainability metrics and impacts to local water resources using a water quality modeling and assessment tool, the Prioritize Target Measure application. Houston Engineering will provide an overview of Field to Market's 8 sustainable metrics, how they're used within the ag food supply chain to meet consumer demand for sustainability grown food products, along with the summary of the 12 farms that have participated in year 1 of the project and how their scores compare to the project, state, and national benchmarks. Please welcome Doug Thomas.
Sorry, I just broke. Can everybody hear me?
Now we can.
Yep, we can.
Right. I just broke the first rule of all of these video things. I forgot to unmute myself. So again, down in the corner, Doug Thomas with Houston Engineering. I'm going to actually close my video so that I can make sure we've got a good stable connection and you're able to hear me throughout the presentation here, and then I'll probably share myself again if there's going to be any questions at the end. And Jamie's going to be running through the slides for me. I appreciate doing that. I don't feel too bad for everybody, but I happen to be in Arizona. So it's a little warmer down here today than it is back in my home state of Minnesota and your project area over in Lafayette County, Wisconsin. So, but anyways, first off, I just want to say it's really a pleasure for myself and on behalf of Houston Engineering to really be involved with this project, and really like to thank LASA and the Dairy Strong Sustainability Association for this opportunity. It's been exciting, it's been rewarding, and it's been a privilege for us to work on it, and look forward to another 2 years of working with the group. So the objective today was really to begin to give you some insights into the first year of the project, all the data that we've collected, the information that we've asked the 12 farmers to provide, and also some of the work that we've done to look at local water resources. So today, my objective is to show some of the sustainability of farms using those nationally recognized metrics, field to market in specific, and then showing the impact of existing and planned conservation on local water resources. And I think that's really a growing thing for us, is that, you know, people want to, you as producers in particular, if you're being asked or being recommended to do something, to change an operation, to add a conservation practice, at the end of the day, we want to know that we're making a difference, that you're part of helping something or improving a situation. And so I think that's really a key part of this. And a lot of that is the data and information, as I said, to tell your story, to share that work that you're doing in the community, sharing it in the region, the state, and nationally, and also with brands and retailers. I think Steve touched on a little bit of some of those influences that you see and we see coming from that agricultural food supply chain. Next slide, Jamie. So again, today we're gonna focus on those environmental aspects of the project. There will be a time when you get to hear more about some of the finance and economic work that's being done by Southwest Tech. But again, today, the on-farm sustainability metrics using the field to market Fieldprint platform, and then looking at local water resources using the Prioritize Measure application. Next slide. So I want to say a few things about reporting out for the 2019 crop year. And the data that we're going to be presenting today, I really need to emphasize it's preliminary. And the 2019 was a challenging year for us all with COVID, travel restrictions, local staff changes that occurred at the county level were all things that kind of pushed us back a little bit farther than we'd like to be. So today we're still really at that preliminary stage of presenting data. Each of the, you're going to see some farm level data that's being reviewed for accuracy with each grower. And that's really important because we want to make sure when we actually publish the results and you have those, that they're going to be as accurate as we can get. We'll be adjusting some of the data that you see will be based on that data review and doing some modifications to some of the data entry. And then the last thing I do want to mention to everyone is that the project does operate under a strict confidentiality agreement. And so when you see information presented on the farms, you're going to see that where it's anonymized and aggregated. We'll never show individual farm results unless the farmer or the grower has said that they've given permission to do that. And that might be something that, as we publicize the project or DSSA and LASA does that, that might be something that people would look for and that might happen. Next slide. So just a little bit on the statistics for the project. It is enrolled with field to market as a field to market project. So it has that status with them. The crops that we analyzed for 2019 included alfalfa, corn grain, corn silage, soybeans, and winter wheat. As you heard before, 12 farms are enrolled. We collected data and generated Fieldprint Platform results for 140 fields that represented 3,357 acres of roughly 29,500 acres managed by the 12 farms. Next slide. So what is Fieldprint Platform? To kind of boil this down, it's a free confidential tool used to explore relationships between farm management systems and operations and the natural resource impacts. The tool is a way to estimate operational efficiency and to help highlight areas of potential improvement. And that's kind of the idea of a score, and that score being compared against other things. Field to Market and the Fieldprint Platform measures 8 sustainability metrics, and those were developed over a number of years. Currently, there's over 50 projects throughout the U.S., and Field to Market is supported by over 135 partners coming from 5 sectors within the agricultural food supply chain. So we think it's a good way for a project like a sustainability project like you're doing in this particular project is a good way because it has that national recognition. And the 8 metrics are kind of on the right-hand side of the screen, ranging from biodiversity, greenhouse gas, land use efficiency, soil conservation, water quality, and I won't go through and read those individually. Next slide. So the field to market the Fieldprint Platform, I'll oftentimes refer to it as the calculator. That is the system that generates these farm field reports. This is an example up on the screen of what an individual farm field report would look like. It's going to include where there's enough information on a crop being grown that there's state benchmarks and national benchmarks. It represents it as what they kind of call or refer to as a spidergram. I like to think of it as your carbon, like a carbon footprint. Obviously, when they talk about carbon footprint, smaller the better. So the smaller that blue blob in the middle of the spidergram, basically the more that farm is, or that field is being managed and operated in a way that's minimizing the impact from the relay in terms of soil conservation or soil erosion, building soil carbon, limiting or minimizing energy use, greenhouse gas. And so it's a way to kind of very quickly see for that particular field how it matches up against those metrics. On the left-hand side, this is, for example, would be a field of corn grain. I just picked out the soil conservation metric. It gives you the measurement. In this case, it was 2.6 tons per acre per year. And it basically tells you how that score was calculated and then basically what it is numerically compared to other national, state benchmarks and project benchmarks when we're able to generate those. And this, so each of the 12 farms that are participating in the pilot project, they get one of these reports for every single field that they have that was entered into the system. So next slide. So then, so once we move past that field level, and that is the information I just showed you, that is the confidential data. The only person that has access to that is an administrator in the system like myself, or the individual farmer, or the farmer who's given that access through delegation to their Fieldprint Platform project. So what we did then is we basically took that individual, those 140 fields, and we broke it down to crop type. So corn grain, corn silage, and alfalfa. And because we had enough there that we either had 8 or 10 unique representative farms that had entered data for those crops, and we created a farm level summary report. In that report that each farmer gets, there's a map of which fields were enrolled. It provides them with the farm average scores. And so it also, the report lays out and provides an explanation of what each of those 4 metrics are that are represented on the left, which are soil conservation, soil carbon, land use, and water quality. We gave them a full Fieldprint platform report for a single field so they could kind of see exactly what that looks like and how much and all the detailed information that comes along with it. And then again, each farm is registered in Field to Market, so they're able to access all the information themselves by logging on to the website. They can add fields, they can modify crop rotations, they can modify inputs based, and that's that process we're going through right now with each of the farms, is making sure that we have that information as accurately put into the system as we can for 2019. So kind of shifting over to the left, and we think this is was a nice way to kind of show it's not all 8 metrics. We picked 4. We picked 4 because those we think were the ones Josh Camps with the UW Extension kind of helped say, well, what are some of the things that you've been talking about as a group, and what are maybe some of those metrics that resonate with the project? And so we picked those 4. And so if you looked at it with corn grain, this was a farm level summary where they had 1 field of corn grain, 3 fields of corn silage, and 2 fields of alfalfa. So they were averaged out. And it shows in this case that at the farm level, their soil conservation score was less than the benchmark. So in that case, smaller is better. And it also has Wisconsin and US averages. And so they could see exactly kind of how they compared there in a very simple way. When you move over to soil carbon, that metric, the larger the number, the better the number. So in this case, their management practices, tillage, crops grown, are all combined, are basically increasing the amount of soil carbon in the soil. So 0 would be neutral, -1 would be losing carbon, +1 would be on the high end of building soil carbon. Land use efficiency is really just a measure of how productive you are in terms of the tons or bushels of commodity being grown in comparison to the area that they're being grown on. And so it really is basically, in this case, it would be acres per, or the unit of production per acre. And then water quality, that's on a scale of 1 to 10, 10 being better. In this particular case, it's very clear. You can see that, the score for water quality was a little less than the project benchmark of the 12 farms. And where there's an NA, it basically said it's not a metric which is compared at either a state or national metric. The value here is that, each farm now can kind of take a look at it and say, well, what would I consider doing, or what are some of those things if I wanted to look at that water quality score and say, well, what influences it and what can we do that might improve that? Obviously, you know, anything that happens here should be done with that trusted advisor or a local conservation professional, because obviously anything that anybody does, you want to make sure that profitability is always first and foremost in any recommendation that you might have. So that's just a real quick description of that farm level summary report that each of the 12 farms has been provided after year 1. Next slide. And so the next 3 slides are going to be the Fieldprint Platform results for the farms that participated in the project. And I want to again emphasize this is preliminary data. But what it shows in this case is it's corn grain, and we just picked out of the 8 metrics the Soil Conservation Index, which is tons per acre, you know, estimating that's being lost per year, with the lower score being better. You can see here the project benchmark is purple, state benchmark is blue, national benchmark is that green line. So for the most part, with a small, you know, a couple maybe small exceptions, this group, its soil conservation score is, you know, better than both state and national averages, and people can kind of see how they compare against themselves. Again, want to caution, we're going to be meeting with every one of the producers and making sure we've got some of those things right. Next slide. This is an example of corn silage for total energy. And, you know, again, you can kind of see, you know, kind of where the farms, in this case, there were 8 farms that grew corn silage that reported that fields in 2019. And again, the nice story that is being told here is overall, the farms are, you know, their management systems, their operation systems, crop rotations are such that the total energy use is below, again, state and national averages. So again, that's a really good story that can be told. Next slide. And here's one for alfalfa, and this is a case where in alfalfa, the field to market does not have enough data points within the state of Wisconsin or nationally to be able to show a state or national benchmark. So really what we're able to do is show a project benchmark. And again, water quality index, 0 being, you know, poor, 10 being very high. This really shows again that collectively those management operations and those farms that are participating are really excelling at the things that you need to do. And you can really see that when I look at the rotations and I see the, you know, the cover crops that are being used, the conservation practices that are being used, the tillage systems that are being used. Those are all of the things that really, you know, influence that score. So again, a very good story and data to support that story with respect to water quality. Next slide. So what I tried to do is get you thinking about that field level, the farm level, the project level, the project level in terms of farms kind of being, you know, comparing yourselves against one another. We're going to have a farmer to farmer meeting, hopefully here in the next month or so, where we're going to be able to talk about how do we maybe, you know, show that data, how do we want to represent it, you know, so that it really is kind of fitting the needs and as some of the things that Jim said, that mission that you have in terms of showing and demonstrating, you know, that good work that's being done. So what I did is I took that and just said, well, what if we just took the project as a whole? I took all the farms, aggregated those scores, and said, how are those comparing against metrics that have state and national averages? And so you can see for corn grain, basically for the metrics where they have, where they're state and national metrics, this average score for the LASA project and the 12 participating farms is higher than state and national benchmark values. For greenhouse gas, it was comparable to state and national benchmark values. And you can kind of see that for corn silage. So again, I think this is a really powerful way to help tell that story of sustainability for those, you know, farms that are now, you know, that are participating in this project. And if, you know, so that's all I'm going to kind of cover on the Field to Market Fieldprint platform, but hopefully starting to give you a sense of, how that data is presented. I'm not going to go into today, the data collection, the data, what all those data pieces are. We'd be here for a lot longer than you would like. So with that, we're going to shift gears and move into the local water resources piece. So next slide, Jamie. So as we shifted to gears to this local water resources, you kind of remember we wanted to look at a way to develop a project around some national sustainability metrics that were connected into that agricultural food supply chain system. Now we're kind of shifting to those, those rivers, streams, creeks, and wetlands in the county. And what is the work happening on farms, and how does that impact? Is there a positive impact? Is it a neutral impact or a negative impact to those? So the idea and the objective of the local resource assessment that we conducted for you was to really expand from that traditional edge of field, where we say, well, here's how much soil erosion is leaving a field, how much phosphorus may be leaving a field, and nitrogen, to really expand that to understand, well, what is that when we get down to that lake, river, stream, wetland, or lake? So it's going to give us a watershed understanding also of nitrogen infiltration risk. I know this was an important issue that you folks had, was groundwater, and you're having a study being done right now to look at, the nitrogen, impacts to groundwater. So that was another one of the objectives, was to basically help you develop an understanding of what is nitrogen infiltration risk. And that's a way for then, the group to start thinking about, well, how do we promote certain practices, target work in certain areas that maybe are going to have a greater impact on protecting or reducing that risk of infiltration of nitrogen into the groundwater. Historically, we've measured benefits of conservation, and you've probably all seen this in your report: miles of grass waterway, tons of soil saved, all great measures. But I think more and more people are asking the question of us is, well, how does that relate to a water quality standard? Steve talked about the Chesapeake Bay, which had a TMDL, which said you can only pump this much phosphorus into the bay, and when you exceed that, then that water is going to decline in quality, and you're not meeting that total maximum daily load. And, potentially down the road, it could trigger some regulatory implications. And the other thing, we want to make is, if there was a goal that somebody set for, well, we'd like to reduce sediment or the amount of soil getting into a stream by a certain percentage. This is a way to begin the ability to talk about those practices and change the way in which we present that information. And again, so that's kind of ties into that predicting the environmental benefit of planned conservation practices. So we can account for existing, but also if you said we're going to increase cover crops by 30,000, well, what might that look like in terms of a water quality benefit? And then I think, also information, which is always very powerful, to help create that dialogue around ag and water quality and quantity issues, in your area. Next slide, Jamie. So I want to just use this slide to mention briefly the project area. You can see Lafayette County outlined in black. Because this local water resource assessment is really based on watersheds. It's basically capturing all of the area where water falls and drains to a specific point, whether it is a sub-watershed, minor watershed, or major watershed. And so this is the scope of the area that we developed the data for to be able to do the evaluation and the assessment. We've completed that source assessment, is what we call it, for both sediment, total phosphorus, nitrogen to surface water, and then we conducted a groundwater sensitivity analysis. So the example that you see here is one that looks at sediment, and it's basically showing from the standpoint of where in the water, where in this large project area, a low potential, medium potential, or a high potential for sediment yield to reach those outlets or those watershed outlets on the bottom of the map there identified by those green points. And so that begins to give you a very graphical way and a visual way to think about, well, where is the sediment coming from that is getting into or leaving the county at those watershed outlets. And so kind of, again, starts saying, well, where would we maybe want to think about maybe focusing work if we were, really concerned or wanted to be concerned about sediment loss. Next slide. And again, so then the way that the tool operates is we started with 75 what we call priority resource points in the project area. So if you look at that upper map, there's a little red square, which kind of gives you some idea of where this is. But what we did is we basically put in priority resource points at a number of different places where kind of watersheds came together. And I put this up here to show you the level of detail that is available and that you can get at with the PTM app tools. So in this case, it's also showing potential sediment delivered to a priority resource point. In this case, it's, and then again, there's 75 of those. So as you were to work with this data, or we work with you working with the data, we can basically say, well, what is it over at this priority resource point? What's it at this priority resource point? And those are all, on a map that, you'd be able to readily see. So in this case, again, it's showing the low, medium, and high potential for sediment delivery, and gives you, again, a sense of if you were going to target work, well, where might you think about doing that? Next slide. And I mentioned groundwater sensitivity, and because groundwater really doesn't, understand those surface water boundaries as much, we don't show it on a basis of watersheds. We show it on a geographic area. So in this case, the project area is, again, that large area, but it basically is a representation, in this case, of nitrogen infiltration risk. So the darker the shading area, the tool is saying that's where you might see a higher risk or greater risk of nitrogen infiltration into the groundwater. And it becomes the basis for the planning to say, well, what would we do if we implemented X number of practices? Or what if we targeted work in a certain geographic area? Because the idea here would be, well, how do we minimize that risk in these areas where the potential is high? And so, and there's some other things that as we start working with you in the next, year, to really start using this to kind of help you think about implementation and achieving some of the goals and the mission that you have in the project area. Next slide. So now we're going to shift gears and kind of start wrapping things up here with the local water resource assessment. So we're going to zoom back out to that large area that defined, where we collected all the data for, generated those original source assessments. And what we're going to do is walk through an example of how the tool was used to evaluate the impact of both existing and planned conservation on a local water resource, or one of those priority resource points. We're going to use soil erosion as the example today, but it can also be run for total nitrogen and total phosphorus as well. So what you're seeing there is the large project boundary area, the county boundaries. The orange are the 140 field to market fields there we put data entry into, which included capturing management practices, conservation practices, cover crop, nutrient management. And that's why we wanted to really show this example to make that connection for at least the field to market portion of it back to that local water resource. That can be done at any scale, and it can be, it can use, multiple ways in which to look at that. So keep that in mind, that image and where that little teal watershed is in the kind of in the center of the county. Next slide. So what we're going to do now is kind of that teal area is what you see over on the right hand side, and that's what I'm kind of calling our area of focus. What we do with the PTM app tool is you run a baseline condition for the entire project area, and that allows you then to build existing implementation and or future condition assessments, comparing it against that baseline. And in this case, we're going to use this and do this in this area to look at the impact of conservation practices. And I want to talk just a little bit about the colors. Again, those orange fields that are showing up, those are the field to market project fields. The teal watershed is the outside boundary of this evaluation area. We did another one at that smaller yellow bounded subwatershed, and those stars are basically where we tell the tool, this is where we want it to calculate the impact first of what is the baseline condition, what is the impact from existing, and what's the impact potentially from future. I guess I kind of think of it as, Siri, tell me what the sediment loss is from this point on the landscape. And so that's the way you tell it where you want it to do it, and the tool generates that information. Next slide. So then, so that is that kind of focus area. And then again, thinking about those, where is that evaluation conducted at? It really everything starts at that field level. And the tool goes down to roughly 30 to 40 acre size areas, because it is based on watershed. And then in this case, we build up to that first star or that outlet point with that where we showed that yellow watershed. And so that would be kind of the level 2 evaluation. Next slide. And then we basically, and this again could be done anywhere in the county for any one of those priority resource points, but then we basically say, well, we want to know what that impact is at Silver Spring Creek, where this watershed dumps into the creek at that particular point. Next slide. So I'm going to spend a little bit of time here because we talked a little bit about baseline condition, and we start and run on any geographic area using what we call a baseline condition. So in this case, we used the crop year, which 2019. The tool goes out and looks at some national databases, and it knows if it was basically reported as corn grain, silage, soybean, alfalfa. We use a typical tillage operation, which in this case would be tillage that would leave 15 to 30% residue at the time of planting. We use a 2-year rainfall event, and for that last one on there, Russell stands for Revised Universal Soil Loss Equation, and it requires a cover factor. And in this case, we picked that the cover, it's a cultivated use for those areas that are in cropland. Other areas, obviously, that are not in cropland, it would have a C factor reflected of if it's forested, water, wetland, or pasture or some kind of perennial vegetation. So that's that baseline condition. So then that was we run that for the entire watershed already. So then we went back in and said, well, now let's look at this watershed. We wanted to break it out into those stewardship fields, which are the orange ones, which are your field to market ones, and capture that conservation and management practices that the farms that participated and reported and were put into that. Then the other area we call them as benchmark fields, and it's simply we needed a way to distinguish between field to market and benchmark. And again, the caution here is we wanted to show that in this evaluation, basically the impact from those field to market fields, those field where we did the Fieldprint Platform data entry. This is not to say that the other farms don't have that same level of conservation. You can actually see on the map, there's plenty of areas that are contour stripped that are outside of that. But we wanted to basically just show an example of how you can kind of select out an area. So we called the fields that we had data put into the Fieldprint Platform as stewardship. Those fields outside of that, we call them benchmark. And then everything started off with this baseline condition. Next slide. So then what we just want to show the kind of information that's collected in field to market that collects information on field management. So so the farmer puts in whether they're using cover crops, for example. We kind of use conservation cover, basically rotations that have long-term rotations with alfalfa in them. whether there's reduced or no-till, strip-till, and structural practices. And you'll notice up here that terraces aren't on there, and that's something that we will mention a little bit later on, is that that's kind of going back and doing that fine tuning. So I wanted to point out here that the opportunity exists to capture other conservations with expanded inventory of practices, either within, using field to market and expansion of that, or even just other local inventory. So we can basically work with the group in 2021 to say, how might we want to capture, more of the conservation that's already going on, to show what the impact of that is against that baseline condition. But again, this evaluation is focusing on those field to market fields, and you can kind of see graphically on the right the kind of conservation measures that were reported within the Fieldprint platform. Next slide. So this is getting pretty close to the end. I'm going to wrap up here. We can go, this again can be done at so many multiple levels, but we wanted to kind of show at that first small watershed, that yellow bounded watershed, what would be the impact if we added, of those measurements, kind of looking at the baseline versus existing conservation. And you can see anywhere from about an 18 to a 52% reduction. So you can we can begin to give you measurable information to say that if these things are being done, the tool is kind of saying that there is anywhere from 18 to 52% reduction from that baseline condition. So that's kind of at that small scale. Next slide, Jamie. And then moving that to that larger watershed area is saying, taking a look at it and saying, well, what was the impact of conservation there on, from those fields? Again, anywhere, if we look at it from the green bar in the middle, which is kind of that existing conservation from those field to market fields that were put into the system, it's a 35% reduction from baseline at that point in the landscape, and almost a 50% reduction from just that kind of benchmark condition through that small watershed. So I think, the value here is you can start to see how we can continue to use that, or the project can use it, to begin to identify and show the benefit of existing conservation practices on those local water resources. Next slide, Jamie. So then another one of the powerful things that this tool can do, and I think this is going to be something that we will work, we want to work a lot with the board and members, is, well, how would you think about future implementation scenarios? And so in this case, we basically asked the PTMap tool to say, what would be the pollutant reductions for sediment, nitrogen, phosphorus if we implemented cover crops on 50% of all of the fields that the soils and everything else were, suitable for cover crops? And so it shows you, in a measurable way, that if in this watershed, the farmers collectively implemented cover crops on 50% of that area, you would have a sediment reduction of 55,837 tons per acre per year. You'd reduce nitrogen loading to that stream at that watershed outlet of 3,914 pounds, and you'd reduce total phosphorus by 194 pounds. So you can kind of show that measurability of it. This is the kind of implementation scenario that I think is really the most fun part for a group to play with, because you can begin to refine it on farmer insight and preference. Well, what practices are acceptable in an area? So you're basically putting into it those practices that there's a likelihood that there would be a higher rate of adoption. Other site-specific information, and you can kind of use it to say, well, what if we did cover crops and another conservation practice, for example? So this is the kind of ability to show that future condition, or kind of what might you expect if you implemented more conservation. Next slide, Jamie. And then to kind of just zoom that way back out to that major watershed, or that large area. So we just basically ran the same scenario to give you an idea of what that would look like. And we said, well, what if we did cover crops on 50% of all feasible acres within the large area. Those light shaded areas would be identified as farm fields that were, that the tool said would be feasible locations. And then what would be the existing load versus the future load. And so in this case, if that scenario was implemented, you might expect to see a 35% reduction in sediment, leaving the county at those 4 red points at the bottom, a 24% reduction in total nitrogen, and a 20% reduction in phosphorus. And so again, that kind of gives that ability to think about how do you want to, maybe how you want to use a tool like this to prioritize, to target, and then lastly, to be able to measure, those, that information. And that's a lot to absorb. And so I apologize if, some of this kind of just, flew by everybody, but with a limited amount of time, we really wanted to give you a taste of what are you getting out of this field market participation? What are you going to get out of the prioritized measure application? So the next slide, Jamie. So I just want to wrap up here with next steps. As again, I've mentioned over and over again, we're going to review the accuracy of the data with farmers for 2019. We'll finalize those crop year farm level summaries. We'll be preparing an annual report for DSSA, for you, and for a few others that are funders of the project. Our goal is hopefully before you're out in the field, we have a farmer to farmer meeting out there where we bring the 12 farmers together. We talk about and explore, how do we want to show this data? Do we want to tease out the grain farmers from the dairy farmers? Because that might not be a good apples to apples comparison. That's one example. How do we want to start publicizing the results? Start year 2 of the data entry. Opportunity to expand to more farms in 2021. Work with, again, LASA, the board, the members, to develop some of those ideas for what you might want to do for additional PTMAP assessments and implementation scenarios. You own it, you have the data, and actually over time, with maybe a skilled GIS person at the county level, this is something that you can just keep doing over and over and over again if you wanted to. And again, use the information to have a conversation about conservation and show that the conservation practices benefit local water resources in the community. Again, help target and market programs. You've got local cost share. How do you maybe want to target that? Maybe more so than you're doing or not. And then lastly, support grant applications. This is the kind of stuff you can go to somebody and say, well, if we implement these many practices, we now actually can show you, or a prediction of how much benefit that's going to occur to a local resource. That's a powerful argument, and that's really, I think, where I see the federal government, USDA, NRCS in particular, with their competitive grant programs. They want to know, what you're doing is going to have a measurable impact or benefit to a water resource. So that's where I'm going to end it. Probably took a little bit longer than the time you guys had given me, Jamie. I apologize for that, but I'll stop there and turn it back to you.
Thanks, Doug. Is there any questions out in the audience? Otherwise, I do have a question that we can start off with. Doug, the question here on the floor is, do higher scores mean the farmers are doing a better job at protecting the environment than the state and federal benchmark?
It's going to do well in the examples that I showed. Each benchmark is, has its own way of scoring. And so, for example, the ones that I showed today, if you're below that state or national benchmark, yes, you are doing better. It means that the practices that you've implemented, the management operations that you're doing are resulting in a score that is better, which means that your operation, if I were going to, characterize it to somebody, you would have a higher sustainability score than that state average or national average. Individual scores, it's going to be different. For example, the soil carbon. A positive number is better than a negative number. On the greenhouse gas emission, a lower number is better than a higher number because you're generating less greenhouse gases with a lower number. So, and that's where that kind of little spidergram comes in nice, because it kind of gives you a very visual way to look at that field level. But the bar graphs that I showed today for the project most of those were basically where there was a state and national benchmark shown, you were doing better. If we had that, for example, with alfalfa and the water quality, you guys were up and around 8.5 or so. If there were state and national benchmarks for that, I can guarantee they would be below that. So that would have showed the inverse of what you saw with some of the other ones.
And I have another question. In regards to alfalfa, when will benchmarks be available for alfalfa?
We're going to be working with Field to Market and really trying to explore a couple things with them in 2020. One is, I neglected to say that some of the data that they're using to generate those state and national benchmarks are dated. The period that they're using is 2008 to 2012. They're going to be updating those in 2021. So one thing that, for example, we're going to want to discuss with the group is it's using Wisconsin statewide averages for fertilizer input, and it's like 90, 20, 25. Well, we know that is extremely low, probably for today's, farming, even across the state. More importantly, in your area where yield goals are, look to be anywhere from 210 to 240 or 50 bushels per acre, you're probably more like Illinois. And so maybe we want to use an Illinois metric for that. And then we'll also be trying to, with this project now coming on and a few other alfalfa projects on the East Coast, we're hoping to get Field to Market to say, and have that science advisory committee say, yes, we have enough data points now to create those state and national benchmarks for alfalfa, similar to what they've been able to do for soybean, corn grain, corn silage, wheat, rice, and some of the other commodity crops.
Does anybody else have any follow-up questions?
Doug, question on the alfalfa water quality slide. There was 2 farms that were lower and the other 8 were pretty average. Do you remember what kind of separated those out?
That's a good question. And again, I'm going to be a little bit cautious because I know that, for example, there are some farms that had terraces in some of those fields, and the Fieldprint platform by itself does not automatically provide a conservation benefit or a higher score for terraces. The reason, and to get kind of a little bit detailed, is that what a terrace does is it breaks your slope length. So if you had 180-foot slope length, you put a terrace in there, you're breaking that to 90, that's going to reduce the potential for soil erosion because water doesn't have the ability to gain speed as it moves 180 feet from where a drop of water falls to where it enters into that spot in the field where the flow gets concentrated, like a waterway or a drainage way. So there's a manual way to do those, and that's one of this process of checking that. We had a few situations where there was some different guidance on Field to Market on how to take credit for cover crops, and there were a few alfalfa fields where when I started looking at them, they didn't check cover crops, and we should have checked cover crops because the question in Field to Market is, do you use cover crops in your rotation? Not, obviously, you wouldn't use cover crops in a year you're growing alfalfa. So those are a couple things that can influence, and that's why we want to be real careful at this time to say it's preliminary, because we may see those some of those scores change a little bit. But a lot of it is just going to be on that water quality one. Soil erosion is going to be a big influencer of that because of the amount of total phosphorus, sediment, and total nitrogen that's connected to the loss of soil from a field.
I think that's all we had for questions, Doug. Thank you very much for that presentation.
Well, again, thank you. And, I'm looking forward to when we're going to be able to kind of dive deeper into the data and show you a lot more of it, as a group out there. And so we're looking forward to that opportunity here in hopefully the next month or two.